Warm welcome you all to channel Meet MIT, that is Math is Tricky.
Warm welcome you all to channel Meet MIT, that is Math is Tricky. In this video, I'm going to share some tips and tricks about derivative. In previous video, I have already shared some tips and tricks about derivative. I have solved many more problems also. Especially in this video, I'll be solving problems regarding application of derivative. Okay, so let's see the first problem. The first problem is here: fx equals 3x squared minus 6x plus 4, and we have to find absolute maxima or minima on the interval minus 1 comma 2. Okay, so for this, to find absolute maxima or minima, please remember these steps. First step will be here. First step is find dy by dx or f dash x. Second steps will be here. Second is here for make f dash x equal 0 and find values of values of x. Step 3, after getting the value of x, find the functional values at the points obtained from step 2 and endpoints of given interval. Okay, interval. You can see here in each question interval is given, so you have to find the functional value at the points which are obtained from step 2 and at the end of the given interval. Fourth one, now you make the conclusion. The conclusion is simply here: greatest value will be absolute maxima. Okay, the least value will be absolute minima. Okay, so one more thing you have to remember, that absolute is also termed as global. Okay, so don't worry, global or absolute is same. Okay, they are the same thing. So these are the 4 steps. You remember 4 steps, and I'm sure if you complete these 4 steps, you will have the answer. Okay, first step is find dy by dx. Second step, make it 0 and find the value of x, maybe values of x, maybe 1 or 2 values. Third step is, after finding the value of x at that point and at the end of the given interval, we have to find the functional value from the given. Okay, among the functional values, we have to see which one is the greatest one. That is going to be our global or absolute maxima. Okay, and the least value, the smallest value, will be the global or absolute minima. Okay, so applying these 4 steps, I'm going to solve one by one, and hope you remember these steps. Now let's see the solution for this given problem. Question number 1. Let's solve the first one question. Fx is given to be here 3x squared minus 6x plus 4. Okay, So let's find first derivative. F dash x will be simply 6x minus 6, and f dash x equals 0 gives 6x minus 6 equals 0, therefore x equals 1. Now we'll be getting here, now if we solve this, so we'll be getting this. Now let's find the value of f of minus 1 first. So we're getting here 3 minus 1 is square minus 6 into minus 1 plus 4. So simply it will be here 3 plus 4 minus plus here. Okay, so 6, 13. This is one value. So f of 1 will be, let's find here. So f of 1 will be 3 into 1 square minus 6 into 1 plus 4. So 3 plus 4, 7 minus 6 is here again 1. This is 1. The third one is f of 2. So let's find at the extreme point of the given interval. So it will be simply 3 into 2a square minus 6 into 2 plus 4. And is here 4th is a 12. 12 plus 12 minus 6, 12 cancel, it is here simply 4. So what we can write here, we have now the greatest and smallest value. So we'll have the absolute maximum or minimum. We can write here greatest value is, which one is greatest? 13, and least value is how much? 1. So we can write our absolute maxima is, so absolute maxima equals 13 and absolute minima equals number 2. So simply it is yes or else. First one solve. Number 2. Here we are given fx equals 2x cube minus 9x square. So as before, according to our first step, let's find first derivative. So it is here 6x square minus 18x. So if we can take here 6x common. So what we are getting here, 6x common is x minus 3. So for f dash x equals 0, we'll be getting here 6x times x minus 3 equals 0. Therefore we'll get here either x equals 0 or 3. Now we'll be finding the functional value. Let's find here f of 0 first. So f of 0 will be simply 0. F of minus, this one finish 3. Let's find here 3. F of 3 will be 2 into 3 cube minus 9 into 3 square. So 27 into 2, 54 minus 9 into 9, 81. So 81 minus 54. Let's subtract this. So it is 7. 7 minus 5 is 2 minus 27. Let's find. We have calculated the functional value for two stationary points. Now move for next one, f of minus 2. It gives here 2 into minus 2 cube, 9 into minus 2 square. So it is here 8, and 8 to the 16 minus 16, and minus 4 into 9. 4 into 9, 36. Okay, so it is here minus 52. Let's find other values. So the last one is here f of 4. F of 4 will be how much? We are doing here second number. So 2 into 4 cube minus 9 into 4 square. So it is here 4 4 16. 16 into 4 60 60 of 16 4 16. Oh, 16 64 into 2, 128 minus 16 to 144. So 144 minus 128. So it is how much? 14 minus 8 is 6, and it is here 13. 13 minus 1, 2 is 1. 16, it is minus 16. Okay, so now we can see here um, we have the function value. Which one is the greatest one? Greatest one. We have four values. 1. This is 2, 3, 4. Okay, among these, greatest is here. Which one is greatest one? See here. Greatest equals greatest value equals 0, and least value equals minus 52. Therefore we can write here absolute maxima equals 0, and absolute minima equals minus 52. That's your answer. Okay, let's solve another question. Question number 3. So as I told you, please you follow the steps that I have given, and by following the steps properly you will have the correct answer. Okay, let's move to third one. Question number 3. Fx is given here x cube minus 6x square plus 9x. Okay, so what's your answer? Let's find first derivative. As I have given the steps, just I'm following that. So it is 3x square minus 12x plus 9, and we can simplify this. 3 is common, so x square minus 4x plus 3. So we can factorize this 3 times. This is simply 3 times x minus 1 and x 3 times here. So x minus 1, x minus 3. Okay, so for f dash x equals 0, we'll be getting here x equals 1 and 3. Now we'll be finding the functional value. Let's find here f of 0 for this. F of 0 will be simply 0. F of 1 will be 1 cube minus 6 into 1 square plus 9 into 1. So it will be 9. 10 minus 6 is 4. So f of 3. Now for this I have calculated. Now for 3, f of 3 will be simply here 3 cube minus 6 into 3 square plus 9 into 3. So 27, 54. 54 minus 9 into 6. 54. Answer is here 0. So now what we can see here, let's see the greatest and smallest value. So what we can see here, greatest value among this here, 0, 4 and 3. Let's find here also value of fx at x equals 5. So it will be fx 5 cube minus 6 into 5 square plus 9 into 5. So simply it will be here 21, 25 plus 45 minus 25 into 6, 150. So it is here 50 and 170 minus 150. Answer is here 20. So which one is the greatest one? 20 is 20 here. Least value is how much? Least value we can see here is 0, 0, 0. It is here at 0 and 3. 20 is at 5, at So our answer will be simply here. Therefore we can write here absolute maxima equals 20 at x equals 5. Absolute minima will be 0 at x equals 0, 3. That's our answer. Hope you are getting this, and if you like this video, please share this video among your friends, share this among your circle, share this among your family, share this among your friends, and please like and subscribe my channel. Encourage me. Okay, if you have any confusion, share with me. Okay, the question number 4. Here fx is given 2x cube minus 15x square plus 36x plus 10. So we have that x will be, let's find the first derivative. It is here 6x square minus 30x plus 36. So 6 is common, x square minus 5x plus 6, and simply it will be 6 times x minus 2, x minus 3. So f dash x equals 0 will give x equals 2 and 3. Now let's find the functional value. First f of 1, so it will be simply 2 minus 15 plus 36 plus 10. Here it is simply 30, 40, 48. 48 minus 15, it will be simply here 3, 33. F of 2 will be, so for this boundary, and then f of 2 will be simply how much? 2 into 2 give me 8 minus 15 into 2 square is 4 plus 36 into 2 plus 10. It is 16. 16 plus 10, 26. 26 plus 72 minus 60. It is how much? 12, and it is here 38. 38. F of 3, let's find. F of 3 will be how much? 2 into 3 cube means it is simply here 27 minus 15 into 3 square is 9. Then here 3 into 36 into 3 plus 10. So how much we are getting here? 54. 54, and it is here 64. 64 plus 108 minus 15 into 9, 135. So how much we'll get here? It is 172 minus 135. So it is, I think, 7. 12 minus 5 is 7. 6 minus 3 is 337. So we have 37. What are the values? Let's see the functional value. We have here, we can see greatest value equals here 33, 38, and here 37. Let's find here f of 4 also. F of 4 will be how much? 2 into 4 cube is 64 minus 15 into 16 plus 36 into 4 plus 10. Let's see what we are getting here. 128 plus 10 plus here it is 6 for the 24, 144 minus how much will be here? 15 into 16. So 15 into 6, 90. So it is here 9 carry 15 and 9, 24, 240. So 240 is there, and how much will be this? So it is here 100, 254 plus 28, 254 plus 20, it will be how much? 2, 7, 8, 282. So if you subtract minus 240, it will be 42. This is giving 42. So among these four values, see here 33, 38, 37 and 42. The greatest one is simply how much? 42. And then least value is which one? 33. Okay, so we can write here, hence absolute. So but maxima equals 42, absolute minima equals 33, at 42 is at which point? At x equals 4, at x equals 4, 33 is at x equals 1. Hope you understood this. If you have any confusion, please share with me, and please encourage me. Just you need to practice. If you practice a number of times, f dash x is first derivative. Then second step 2 is here, make f dash x equals 0 and find values of x. Step 3, find f double dash x, that is second derivative. Fourth step, examine the sign of f double dash x at the values of x obtained from step 2. Then 5, step 5, fifth step is local maxima. You need to conclude now. Now we have the conclusion. Maxima if second derivative is less than 0, local minima if second derivative is greater than 0. Sometimes local is also called as relative also, so remember this, relative. Okay, so sometimes relative term will be used, this word relative will be used for local. So if you follow these 5 steps, I'm sure you'll have the answer. Okay, to find point of inflection, I'll be writing the condition. So these are the 5 steps. Find dy by dx, that is the first step. Find first derivative. Second step, make it 0. Define the stationary point or the value of x, maybe sometimes 1 or 2 also, more than 1 also. So after that, third step will be always find second derivative. Okay, after finding second derivative, you need to check its sign at the values obtained from step 2. This is step 4. After getting step 4, completing step 4, you will see whether either this second derivative will be positive or negative. If it is negative or less than 0, there will be local maxima, and if it is greater than 0 or it is positive, there will be local minima. Okay, now the local maxima or minima, the value of local maxima and minima will be obtained by putting the value of x in the given function. Okay, so for point of inflection, let me write the condition. So point of inflection, for point of inflection, second derivative dx square will be 0, and third derivative will not be 0. That is f double dash x equals 0, but f triple dash x will not be 0. Okay, this is the condition for point of inflection. Okay, now let me solve the problem and explain it for you. First question number 1. So first number is here, fx is given to be 3x square minus 6x plus 3. So f dash x will be 6x minus 6, and f dash x equals 0, implies here x 6x minus 6 equals 0. Therefore we can write here x equals 1. Second derivative will be, let's find second derivative, which is simply 6, which is greater than 0. So there will be local minima at what? X equals 1, and local minima, the value of local minima will be simply f of 1. Let's put 1 there. So 3 into 1 square minus 6 into 1 plus 3. So 3 plus 6 minus 6 will be 0. So therefore local minima is 0 at x equal 1. Now for point of inflection, let me explain here. For point of inflection, you can see here, for since f double dash x is here 6 not equals to 0, there will be no point of inflection. Okay, this is question number 1. Okay, I've solved it for you. Now let's move to question number 2. So in this video I'm solving problems of derivative, and especially we are dealing with here how to find local maxima or minima. Question number 2, let's see here. Question number 2, fx is here x cube minus 12x plus 8. So according to our step, I have already given the steps. Let's find first derivative, 3x square minus 12. If we take here 3 common, x square minus 4. So f dash x equals 0 gives x square minus 4 equals 0. Therefore x equals either minus 2 or plus 2. Now let's find the second derivative. Second derivative is here 6x. Now when x equals minus 2, second derivative will be here minus 12. So minus 12 less than 0. Therefore there will be local maxima at x equals minus 2, and local maxima, the value of local maxima equals here f of minus 2. Let's put here minus 2. So minus 2 cube minus 12 into minus 2 plus 8. Here minus 2 is here simply minus 8, and plus 24 plus 8. So this and this cancel, answer is here 24. So this is our local maxima. Now let's check here. When we have already checked for it, so when x equals to f double dash x will be 12 greater than 0. So there will be local minima at x equals 2. Therefore local minima equals equals f of 2. Let's put here x equals 2 in the given function, so 3 into, it is here, f of 2 will be 2 cube minus 12 into 2 plus 8, so 8 plus 8, 16, 16 minus 24 is here, minus 8. This is our local minima. Now for point of inflection, let me solve it for you. For point of inflection, so f double dash x equals 0 implies 6x equals 0, therefore x equals 0, and third derivative we can check here is 6 not equals to 0, so point of inflection will be at x equals 0. Okay, this is the solution for question number 2. Let me solve another question for you. Hope you are understanding this, and if you have any confusion, please share with me so that I can help you solve here. Question number 3, f dash x equals how much? 3x square minus 12x, and f dash x equals 0 implies here that gives 3x square minus 12x equals 0, or we can take here 3x common, so we'll be getting here x minus 4 equals 0, therefore x equals 0, either 0 or 4. Let's find second derivative. Second derivative is how much? Second derivative will be here 6x minus 12 at x equals 0. Second derivative is how much? Second derivative will be 0 minus 12, minus 12 less than 0, so there will be local maxima at x equals 0, and local maxima will be how much? The value of local maxima will be f of 0. F of 0 gives how much? If we put here, so it will be simply 3. F of 3, we are doing here 3 number, question number 3, put here 0, 0, 3, we'll be getting here. Now at x equals 4, we take here second derivative equals 6 into 4 minus 12. 24 minus 12 is 12 greater than 0. So there will be, therefore, local minima at x equals 4. And now let's find the value there. So we can write here local minima will be f of 4, and simply let's put here f of 4 means put here 4, x equals 4, x 4 cube minus 6 into 4 square plus 3, so it is here 6, 4 cube is 64, 67 minus here it is almost 696. Yeah, so let's subtract this, so it will be here, if we subtract this, so 96 minus 67, so 16 minus 7 is 9, and 2 minus here minus 29. This is our local minima. Hope you are understanding, and please if you have any confusion, write it in comment box, and please if you want to make me more videos of your interest, so write the topics interested in your interested topic also, so that I can upload video according to your interest. Question number 4, fx is here 2x cube minus 15 x square plus 36x plus 5. Okay, so let's find first derivative. It is here 6x square minus 30x plus 36. Now f dash x equals 0 gives 6 is common, x square minus 5x plus 6 equals 0. So we can write here x equals either 2 or 3. By factorization, we'll get that 2 or 3. So let's find second derivative. And second derivative is how much here? 12x minus 30. Add x equals 2. F double dash x. See here, it is here. 2 means 24 minus 6 greater than, less than 0. It is less than 0. So local maxima, there will be local maxima at x equals 2. Therefore we can write here local maxima equals how much? F of 2, this. And then if we put here x equals 2 into, it will be 2 means 8 minus 15 into 4 plus 72 plus 5, 16 and 5, 20, 1, 21, 22, 23, 23, 93, 93 minus 60, it is here 33. Okay, so this is our local maxima. Let's see here at x equals 3, what we are getting here at x equals 3, next value x equals 3, we have double dash x will be simply how much? It is here 12 into 3 minus 30, 36 minus it is here 6 greater than 0. Therefore local minima at x equals 3. So local minima equals f of 3, and if we simplify this, we'll be getting here f of 3 means 3q is 27 into 54 plus 559, and then 9, 15 into 9 is 135 plus 108. So it will be here 59, 59, 59, 60, 67, 167 minus 135. So what is the answer? 2, 3, I think here 32. Okay, so you can simplify and get answer also. For point of inflection, you can see here for point of inflection, f double dash x equals 0. So we'll be getting here what is the f dash x? F dash x we have already calculated 6x square minus 30x plus 36. F double dash x will be 12x minus 30. So we'll be getting here 12x minus 30, and also let's find here triple dash x. It is here 12. So 12x minus 30 equals 0. It gives here x equals 30 by 12, and it gives how much? 5, 2. This is 2.5. But we can see here f double dash x is 0 for x equals 2.5, but f triple dash x is not 0, so point of inflection will be at, so point of inflection will be at x equals 2.5. Okay, so let's see another question. Question number 5. Hope you are understanding this. I'm solving all the questions one by one for you. Question number 5. Fx is here 2x cubed minus 9x squared minus 24x plus 3. Let's find first derivative. It is here 6x squared minus 18x minus 24 f dash x equals 0 gives here 6 is common, so x squared minus 3x minus 4 equals 0, or we can write here x squared minus 4x plus x minus 4 equals 0, or x is common, so x minus 4 plus 1 common, x minus 4 equals 0. Therefore we'll be getting here x equals minus 1 and 4. And second derivative is how much? Let's see here, second derivative. So second derivative will be 12x minus 18. Okay, so at x equals minus 1, second derivative will be here minus this, minus and minus both, so it is here less than 0, so local maxima at x equals minus 1, therefore local maxima equals f of minus 1. So simply if we put here the value of x here, so we will be getting here minus 2 minus 9 plus 24 plus 3. So how much we are getting? 27 minus 11. 27 minus 11 is 16. This is our local maxima. Now let's see here the value of second derivative at x equals 4. Second derivative is for the second derivative. It is here 12x minus 18. So at x equals 4, second derivative will be obviously here 4, 12 into 4, 48 minus 18, 30 greater than 0. So local minima at x equals 4. The value of local minima will be, therefore local minima will be f of 4. We can simplify this. You can answer here, simplify by yourself. Now let me explain what is the point of inflection. Okay, so for point of inflection, here we have f double dash x is 12x minus 18, triple dash x is 12. For f double dash x equals 0, we get 12x minus 18 equals 0, or x equals 18 by 12, 6 2 is 6 3 is, so it will be here 1.5. But f triple dash x is not equals to 0, so point of inflection will be at x equals 1.5. Hope you are getting this. You can do like this also in a super fast way if you practice well. Okay, let me do next question for you. Question number 6. So fx is given to be here 4x cubed minus 15x squared plus 12x plus 7. So f dash x will be simply here 12x squared minus 30x plus 12. Let me find second derivative also. So it is 24x minus 30. F dash x equals 0 gives 12x square minus 30x plus 12 equals 0. So it gives here 6 is common. If you take here 6 common, so 2x square minus 5x plus 2 equals 0. If we factorize this here, 2x square minus, I think here 4x minus x plus 2 equals 0. So from this we'll be getting here 2x common, x minus 2 minus 1 common, x minus 2 equals 0. Therefore the value of x will be here 2 and 1 by 2. So at x equals 2, second derivative, let's check the sign of second derivative. What is the second derivative? So 2 means 48 minus, so it is here positive. So local minima at x equals 2. Therefore local minima will be how much? Minima will be f of 2. You find by yourself. Okay, f of 2. Now if we put here at x equals 1 by 2, second derivative will be here 1 by 2 means second derivative will check here 12 minus it is here negative. So local maxima and will be equal to f of 1 by 2. Find the value. For point of inflection, let me solve it and show for you, explain it for you. Let's find here third derivative also. Third derivative is here 24 and f double dash x equals 0 implies here 24x minus 30 equals 0. So it is here 24x equals 30. Therefore x equals how much? This is not equals to 0. So it will be here 30 by 24. So it is here 6 5 ja 6 4 ja 5 by 4. So we can write here point of inflection will be at x equals 5 by 4. Okay, let me solve another question. So hope you are getting this. If you have any confusion, please write it in comment box. You share with me so that I can help you. Okay, question number 7. Fx is given to be here simply 4x cubed minus 6x square minus 9x plus 1. So if you find first derivative, it will be simply 12x square minus 12x minus 9. Let's find second derivative. So it will be here 24x minus 12. Let's find third derivative also. So 24. And f dash x equals 0 gives 12x square minus 12x minus 9 equals 0. Let's simplify this. So 3 is common. If we take here 3 common, 4x square will get here minus 4x minus 3 equals 0. So that will be getting here 4x square. 4 3 is 12. So minus 6x plus 2x minus 3 equals 0. It gives here 2x is common. So 2x minus 3 plus 1 is common. 2x minus 3 equals 0. Therefore we'll have x equals either minus 1 by 2 or 3 by 2. Now if we see here now we are given here one interval also, so we need to just check that these two values lies between these two or not. Both belongs to here minus 1 and 2, less than, this is 1.5 and at x equals minus 1 by 2. If we check the sign of second derivative, what we will get here? Second derivative 1 by 2. This is negative, both negative. So we can write here, it means negative. So local maxima at x equals -1/2 and local maxima equals f of -1/2. You find its value by yourself. Now if you put here 3/2, so let's see what is the value of second derivative. Second derivative is here, so it is 3/2 means positive. So there will be local minima at 3/2. Local minima will be here simply f of 3/2. Now for point of inflection, let me explain it for you. We can see here easily this third derivative is not equals to 0 and f double dash x equals 0 implies here 24x minus 12 equals 0. Therefore x equals 1/2. So point of inflection will be at x equals 1/2. That's our answer. Last question for today. Let me solve it for you and then hope you are understanding this. If you have any confusion, please ask me, write it in comment box. Okay, question number 8. fx is given to be here x plus 100 by x minus 5. Let's find first derivative. So it will be simply 1 and then we can write here minus 100x power minus 2. F double dash x, if we see here, we'll be getting here simply 200 x power minus 3. Okay, x triple dash x, if we see here, getting here minus 600 x power minus 4. And for f dash x equals 0, we'll be getting here 1 minus 100 by x square equals 0, or we can write here x square minus 100 equals 0. Therefore x equals minus 10 and plus 10. So at x equals 10, we can see here second derivative. See the second derivative, it is simply here positive. So local maxima at x equals 10 and local maxima will be how much? Equals f of 10. That's our answer. At minus 10, it will be here less than, second derivative, it is here for x, it is positive, so it will be minima. At x equals 10, this is greater than 0, so there will be minima 10. Local minima will be this. Now for x equals minus 10, it will be here, if we put here minus, it is less than 0, so there will be maxima at x equals minus 10. Local maxima will be f of minus 10. Okay, for point of inflection, let me solve it for you. For f double dash x equals 0, we are getting here 200 by x cube equals 0, which is not possible, for any real values of x. So no point of inflection. Hope you are understanding this. Hope you understood this. Whatever I explained for you. Thank you so much. God bless you.
Thank you so much for watching my video. I hope you like this video. Please do share this video with your friends, in your circle, in your social media, and please don't forget to subscribe my channel. Thank you so much. God bless you.